Welcome everybody to our lesson on addition and subtraction with polynomials. So when we talk about adding polynomials, we're really just extending our ability to add and subtract a single monomial. The key part there is combining like terms, okay? So what are like terms? Like terms are expressions with the same variables and the same exponents. Okay, so in order to do that, I have to have the same exponent as another exponent, and the only way I can add those is if that exponent is the same thing, okay? Because x cubed is its own entity, so I can only add another x cubed to it. So if I had 3x cubes and 1x cubed, well, that would give me 4x cubed, right? So we're just going to be doing this simple little thing inside of much larger expressions. So for example, if I had 4x squared plus 2y to the fourth plus 6x plus 7x squared plus 5y to the fourth, I can only add these together when things are like, okay? Again, like terms. So we look at it one by one. I have 1x squared, and I look for x's that are squared. So here I have an x squared and here I have an x squared. So I know that I can combine those two together, right? So I will write that as 4x squared plus 7x squared, okay? Now I look for the next term in here. Well, my next one is y to the fourth. Well, do I have any other y to the fourths in here? I do, y to the fourth. So this term can be added together. So 2y to the fourth plus 5y to the fourth. Now, when I look at that, I've processed all the variables. The only thing I have left is that 6x. So I'm going to stick him out here by himself. So now I just have to combine the coefficients, and that coefficient is telling me how many of each of these variables that I have. So I have 11x squared, 4 and 7, plus I have 2 and 5. Oops, I noticed that I didn't write that as a 4, did I? So this is 7y to the fourth plus 6x. So this would be my addition, my summation of this polynomial, okay? Now, sometimes what you're going to see is an expression where they actually break it out. 3x squared plus 4x plus 2 plus 6x cubed plus 7x squared plus 3, okay? So these are two different polynomials that I have to look through, and I have to set it up so that I am combining like terms. So I look for the highest degree in each one of these, and as you see, I have an x cubed here. I don't have an x cubed, so I know that I'm essentially done with that variable. I look, the next lower one is x squares. So I'm going to have a plus 3x squared plus 7x squared. Now, if you want to, you can combine them into parentheses so you can really see easier what you're doing. So after x squared would be x. So I have an x, but I have no x. And then I have a coefficient with no variable here, plus 2 plus 3. Okay, so I go through and I just perform the summations that I have left to do. So I have 6x cubed plus 10x squared plus 4x, and then of course plus 5, okay? And remember, this 2 plus x, that would be just like saying those were x to the 0 powers, because anything to the 0, of course, is 1. So when I look at this one, this is now written in our standard form because I have a descending order of exponents, okay? So very important to make sure I'm lining up my like terms, group them together, and it will make my math much easier. And if I make a mistake, I'm able to look back very easily. And this is how I can check myself once my work is done to see that, okay, yes, everything does make sense, okay? So let's move on to the next type. So if I can add, then I can subtract, okay? But again, here, everything means still combining like terms. So if I had an expression, 5x cubed plus 2x squared plus x, and that was one polynomial, minus 3x cubed plus x squared minus plus, let's say, plus 6, okay? This minus here has to be distributed to each term on the inside of this parenthesis, okay? If you want to think of it, this minus here is truthfully the same thing as plus a minus 1 times everything in there, okay? So when I go back through and rewrite it, notice nothing will have changed to my first polynomial. So I will write it down. And then I can add the negative of everything that's inside my parentheses, which is the same thing as subtracting, right? So if I'm adding the opposite of 3x cubed, I'm subtracting 3x cubed. If I'm adding the opposite of x squared, I'm subtracting x squared. If I'm adding the opposite of plus 6, I'm subtracting 6, okay? So now I'm left with just, again, combining like terms. And I suggest for right now, you group them together until you get enough practice where you can do it without this step. So then I've got plus 2x squared minus x squared plus x. I don't have an x here. And then I also don't have a constant. So that's plus a minus 6, right? So I just now work my like terms. I'll have 2x cubed plus 1x squared minus 6, okay? So that's subtracting one polynomial from the other where all terms end up being positive inside that parenthesis. So let's do some with just a little bit more variety here. Let's say that I had 7x to the 4th minus 8x squared plus x. And now let's subtract 3x to the fourth plus 5x cubed minus 2x squared minus 4x, okay? So again, I have to take and apply this minus sign to everything inside my parentheses. So I have my highest order here is the 4. So I have 7x to the fourth. I go over here. Do I have any other force? Well, I do, and it's minus that, okay? So minus 3x to the fourth, okay? Do I have any cubes here? No. I do here, but I have to take the negative of whatever sign this is. So I'm going to have minus 5x cubed. Now I have a minus 8x squared. I look in here, I have an x squared. I have minus a minus. Or I can say I'm going to add the opposite of. Well, the opposite of a negative is a positive, right? And sometimes when I'll show you a little kind of trick here in a minute when you're subtracting a negative. But let's continue on here. So I've got a plus x. It's my next lower exponent. I look in here, I've got one minus a minus. That's going to be a plus, isn't it? Okay, so now it's just combining like terms. 7 minus 3 is 4x to the fourth. I only have the 1x cubed. Minus 8 and plus 2 is minus 6x squared. And then I have 1x and 4x, or plus 5x. And then that polynomial would be the difference of two polynomials, okay? So I talked about a little trick. Sometimes people have trouble subtracting a negative. So if I had 8x minus negative 3x, okay? What I can think of is, you know what? If I need to deal with this, I always thought of taking this sign here and kind of thinking about, well, if I want to make this a positive, I can get rid of this. If I bring it over, it slashes down into my minus and makes that a plus. Now this is gone, so I get 8x plus 3x, or 11x, okay? So that's just maybe a little trick to help some of you with subtracting a negative number, okay? So let's look at another example or two. So what happens if I get a problem like this, where I have 6x minus 2x plus 3x minus 4 plus 2 minus 3, okay? Here's where our PEMDAS is going to come in, right? I look to the inner parentheses, which is here. Can I do anything? No. So I can drop these parentheses and look at what is left. So I have 2x, this is a plus, I'm not going to change my signs, plus 3x minus 4, nothing happening here, plus 2 minus 3, okay? So again, PEMDAS, look into your parentheses, okay? So all I can do is combine like terms, right? 2x and 3x is 5x, minus 4 and plus 2 is minus 2, and then that's minus 3, okay? So it carries on down. So PEMDAS, I look inside the parentheses. Nothing I can do. I go outside. I have this minus sign. Remember how I said a minus is the same thing as plus minus 1 times the grouping? So this really becomes 6x plus a minus times 5 minus 5x plus a minus 1 times minus 2, which is 2. So this minus is only distributed to what's inside my grouping symbol. This minus 3 remains unaffected by all of that. Now I'm down to combining like terms. So 6x minus 5x is just good old x. 2 minus 3 is minus 1. Okay? So just another way of handling the distribution of the negatives. Now, if this negative, or this positive, had been a negative, I would have had to change the signs of everything inside that grouping symbol, okay? But it was positive, so I could just carry it on. All right? So there's one other way that people will represent addition and subtraction of polynomials. And if I had a polynomial 3x squared plus 4x cubed minus 2, and I wanted to add it to 7x squared plus 3x to the 4th plus x minus 2x cubed. Now notice I did not write these in any sort of descending order, okay? So these are just randomly ordered polynomials. Now what I want to do here is before I add them, I want to get them in that order. So this one has the highest order, so let's do him first, okay? So I have 3x to the 4th. I have a minus 2x cubed. I have a plus 7x squared. And I have a plus x, okay? Now, here's the other way that you can add polynomials. I can, because this is a positive, I know I've got this polynomial and this polynomial, right? What if I did this in a columnar fashion? My highest degree here is x cubed. What if I said, you know what, I'm going to line them up this way. So there's my x cubed. I have a 3x squared. I'm going to line him up there. And then I have a minus 2. Well, I don't have a constant here, so I'll just put a plus 0 as a placeholder. And now I can go through and I can add this polynomial to this polynomial. So I get 3x to the 4th plus 2x cubed plus 10x squared plus x minus 2. So doing it in a columnar fashion just makes it maybe sometimes a little easier to see what I'm doing, okay? So how would that work if I did a subtraction? Well, let's do that. So if I had 8, and let's pick a different variable this time just so you can see how it doesn't affect anything. 8x to the 5th plus 4y cubed plus y minus 7y to the 4th minus 2y cubed plus 3y squared plus 8y plus 7, okay? So this time I'm subtracting this polynomial from this one. Now, notice a while ago when I was adding, I put the bigger one first. I'm not going to do that this time. So I'm going to lay out this top one and put the longer one underneath. So here I have 8y to the 5th. I don't have a y to the 4th. So I don't have y to the 4th, or I can say I have 0 y's to the 4th, right? And then I have 4y cubed. I don't have a y squared. Y squared. I have a y. And then I don't have a constant. So I'll put him out there. And I'll just put pluses for all of that, because this entire polynomial was all sums, okay? So my operation is subtraction. My highest is a 7 to the 4th. Now notice this guy is in that descending order, which is going to make it easier writing this down here, right? So I have 7y to the 4th minus 2y cubed plus 3y squared plus 8y plus 7. Now I'm going to subtract this from this one. So I have no y's to the 5th. So that's 8y to the 5th, right? I have 0y to the 4th minus 7y's to the 4th. Well, that's just going to be minus 7y to the 4th, right? I have 4y cubed minus a minus 2y. And remember, minus a minus is a plus. So I really get 6y cubed. I have 0 minus 3. So that should be a negative. Okay. Y minus 8. So this is 1y minus 8y. If I think of my good old number line, right? There's 0. The first thing says go 1 to the right, because that's the positive. Then I'm going to go left 8, because that way left is negative. So I have 1, 2, 3, 4, 5, 6, 7. So if I go 8, I'm going to end up here, because I go 1, 2, 3, 4, 5, 6, 7, 8, right? And that's going to be minus 7 here. So I have minus 7y. And then my constant 0 minus 7, well, again, now I'm starting from 0 and subtracting 7, and I'll have minus 7, okay? So subtracting one polynomial from the other is really not that hard if I think of adding the opposite to that very first one, okay? So adding and subtracting polynomials, it's not very difficult, but what you have to do is you have to think in terms of operating on like terms, same variables and same exponents, okay? So that will conclude our lesson on addition and subtraction with polynomials. See you next lesson.